Last video, I got a request for a video on what the graphs on some polynomials look like. And let's start out with some more basic stuff. So, first degree polynomials. And what the degree of a polynomial is the highest power in the polynomial. So, for example, x cubed plus x is a third degree binomial. So, anyway, let's start out with just the simplest of polynomials. How about y equals 2x plus 3? Okay, so this is the graph of y is equal to 2x plus 3. As you can see, the second number here is determining our y-intercept. So that's this thing right here where it crosses our y-axis. And you can see that this 2 determines our slope. If you're not entirely sure what that is change in y over change in x, rise over run. So you can see that after we go 1 over, we go 2 up. So rise is 2, run is 1. 2 over 1 is just 2. And you can see a lot of those kind of things. Like, for an example, say we do, how about 2/3 x? Y equals 2/3 x. Pretty simple. So, since we're not adding anything or subtracting anything, we just have a y-intercept right at the origin. So that's 0. So, since the 3 is the denominator, we go 3 over and 2 up. And we get this point 3, 2. So, sure enough, that is how this kind of works. Now, the thing about polynomials is that they take on different shapes as the degree goes up. So, right now, we have a line. But we can get a shape, a curved shape, called a parabola. So, let's look at just the standard parabola. So that's y is equal to x squared. So, you can kind of see that it kind of curves upward here, curves upward here. And the reason that it does that, the reasoning behind this really is, well, it doesn't keep going down here exponentially because when it might not make sense. It might seem like it should keep going down, but the truth is that when you're squaring negative numbers, the negative signs cancel out. So like -2 squared is just going to be 4, a lot like 2. So now I'm going to set up some sliders here just to demonstrate what these things all do. I'm going to get these down to 0 and 0. So we start with our standard parabola. And now, well, let's look what a does. So the thing we're multiplying x squared by. What we kind of see this doing is it is kind of what we call is the vertical scaling of the parabola. And when it goes into the negatives, well, you see this kind of, well, it's scaled negatively. So it's going down because it's a vertical scaling. And now, how about, I'm going to get this back positive for these other ones so that it isn't too weird. So how about b? So that's what we're multiplying x by. Well, although this looks a little weird at first, this is actually kind of like what we saw with our y's. Because if you just imagine that this half of it doesn't exist, and this half does, and you imagine that it's just a line, you can see the slope kind of going up and down. And just to really demonstrate that, I'm going to put in y equals bx plus c here. And I'll just slide that up with this. So we can see that as we move b around, that's kind of determining that slope right at the intercept. And then with c, that determines our intercept. Once again, the thing we add to the entire thing, that determines our intercept, as usual. So what we multiply x squared by is the vertical scaling. What we multiply x by is our slope, and whatever our constant is whatever the c is going to be our intercept. Now, let's get rid of all this. And let's look at something with what would then be a third degree polynomial, so something with x cubed in it. And by the way, I'd just like to mention, the degree of the polynomial is going to determine its number of roots, and what that means is the number of places it intercepts the x-axis. So it's a lot like an x-intercept for a line, and such as our previous line, y equals 2x plus 3. You just call that the x-intercept in this case, but usually with other polynomials you call it a root, and there's going to be multiple of them. And the degree, whatever the degree is, that's how many roots it has. And we saw that with some of those parabolas. They intersected the x-axis in two different places. Now, look at just our basic cubic function. And I'd like to add some sliders to this. So, let's add all of those in. And now we kind of get the idea of what B, C, and D do from our previous experience with just this kind of stuff. Bx squared plus cx plus d over here. But what does A do? Well, at first it looks like it's literally just what we expected B to do. But it's actually quite different, because this isn't exactly vertical scaling anymore. This actually doesn't have a name at this point, but you can see that it's going to do something different than what B does, which it actually starts to form a little parabola here, which is being vertically scaled in terms of B. And then we have C, determining that kind of slope-like thing. So we can kind of mess with these bits. Let's see when this goes negative. And then this is positive. And then D, as usual, our intercept. And what did I just say about the number of roots earlier? This, in fact, has 3 roots, 3 places where it crosses the x-axis. And I mentioned in a previous video that what this kind of stuff was used for was roller coaster designs. And you can start to see why, kind of, because those parabolas kind of had this kind of curve to them. And now this kind of curve, you can see the shape of this really looks like something you might see on a roller coaster, like where it goes up and then down and then quickly up again, or something like that. Now, let's get rid of all this. I forgot that I could just go to Edit List and click Delete All, so I can just do that. Now, what kind of thing is y equals x to the 4 going to look like? Because we've seen some very unique shapes. Well, if you imagine something with 4 roots, you might start to get an idea. If that's a little weird for you, hard to imagine, let's look at just the standard. Now, at first you might say, hey, that's just like a standard parabola, except it looks kind of vertically scaled. Well, just look at this kind of bottom part here, and you notice that it's kind of getting flattened, which doesn't really make sense until you think about the fact that these decimals are getting multiplied by things less than, I mean, not just decimals, but like these things less than 1 and greater than -1. Now, they're getting multiplied by stuff. In fact, if we just isolate this part, they're getting multiplied by stuff less than 1 and greater than 0 over here. So that's bringing them down. And same thing over here, except we can consider this because it's just bringing their absolute value down. And now let's set up some sliders with this. This should be interesting. You might notice that I skipped the letter E. That's because E is actually a constant. And I can go over what that means later. I mean, well, you know what that means, but like, not just what that means, what E is. So, first of all, A is a type of vertical scaling. Maybe I'll mess with this in the negatives. So, B, we start to get a cubic looking thing. C, we have kind of even a different type of vertical scaling now that we're seeing. D, this should be really interesting. We see this kind of slope thing right where the intercept is, really, and that makes sense. And then F, once again, this last thing is going to be our intercept, the y-intercept. So right now F is set to -4.1, -4.1. And once again, 4 roots for this. And this looks very much like something on a roller coaster. So you can see how this is used, and you can see how you can kind of interpret the